Children, now the topic is azeotropic mixture. So yesterday I have told you that after the discussion of non-ideal solutions, means the solutions showing negative deviation and positive deviation, we will discuss the next topic, that is azeotropic mixture. So these azeotropic mixtures are related to the solutions which are non-ideal, and a mixture of two liquids which boils at a particular temperature, like a pure liquid, and distills over the same composition is known as azeotropic. Means these are considered to be the constant boiling liquid. Azeotrophs. What is the second name of azeotrophs? Maybe question asked, define constant boiling liquids. So azeotrophs are considered to be the constant boiling liquids. These are formed from non-ideal solutions. Okay, and since we know two type of non-ideal solutions are there, either they are showing the positive deviation from the ideal behavior, or they are solutions showing a negative deviation. So definitely this constant boiling liquid will also be two types. The first one is minimum boiling azeotrophs. The first one are minimum boiling azeotrophs. These are formed by those liquid pairs which shows positive deviation from ideal behavior. Mind one thing, minimum boiling azeotrophs are formed by the non-ideal solutions which are showing positive deviation from the ideal behavior. It is okay. Very simple. Such azeotrophs have boiling points lower than either of the components. Means such example is of ethanol and water. Means the boiling point of ethanol, this is ethyl alcohol, is lesser than water. Water has boiling point very commonly 100 degrees Celsius, and ethanol has lower boiling point than that of water. Even this mixture will boil below the boiling point of ethanol. Means overall this mixture will boil below the boiling temperature of the ethanol. So that's why this is considered to be the minimum boiling azeotroph. It is okay. And this minimum boiling azeotroph shows the positive deviation from the Raoult's law, means ideal behavior. Now the second part, children, I am going to discuss with you maximum boiling azeotrophs. In the same fashion you have to go through. Such type of boiling azeotrophs are formed by those of liquid pairs which shows negative deviation from the ideal behavior. It is okay. And such azeotrophs have boiling points higher than either of the components. Means such combination, means hydrochloric acid when get dissolved in water, then this liquid will show negative deviation from the ideal behavior and will be considered to be the maximum boiling azeotrophs. Suppose, for an example, I am showing here the boiling point of water is 100 degrees Celsius. Maybe the boiling point of hydrochloric acid is 130. Then the total solution, means this solution mixture will boil after the boiling point higher than that of HCl, means maybe more than 130. So such type of solution mixtures are considered with the maximum boiling azeotrophs or constant boiling liquids, maximum constant boiling liquids. So very simple, these are concepts usually asked in your board examination in very short answer type questions, either by example or by reasoning or by definition. So better you go through the detailed study of Raoult's law and ideal solution, deviation from ideal solution, positive and negative deviation with examples, and these constant boiling liquids means azeotropic mixtures. It is okay. How many type of mixtures you have gone through? Two types. The minimum boiling azeotrophs and the maximum boiling azeotroph. Now children, we should have to go through the detail of colligative properties. At very first, we should know what are the colligative properties of the solutions. Properties which depends only upon the number of solute particles. This is very special point. Means properties which depends only upon the number of solute particles in a solution, irrespective of their nature, are considered to be colligative properties. These colligative properties are relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Children, I will give you the detail one by one of relative lowering of vapor pressure by giving the derivation and explanation, then elevation in boiling point, depression in freezing point, and finally osmotic pressure. In osmotic pressure we will discuss osmosis and reverse osmosis, hypotonic, hypertonic, isotonic solutions, etc. I mean, this topic is quite beneficial for you, and you will be getting a numerical from these calculations, elevation in boiling and depression in freezing. So I mean, we will discuss this topic tomorrow. Okay? Better you should have to prepare the notes, whatever I am delivering from the dash here. Thank you. Have a nice day.